All right, let's dive right in. Today, we're going to tackle a really common challenge in modern data centers. How do you get services like firewalls or load balancers stitched into a Cisco ACI fabric intelligently? You'd think it's simple, but the network's main job is to be fast and efficient, and security's main job is to inspect everything. Those two goals don't always line up. So we're going to demystify this whole thing and show you how we move from the old, kind of clunky way to something a whole lot simpler and way more powerful. Okay, so here's our roadmap. First, we'll set the stage and talk about why service insertion is even a challenge to begin with. Then, we'll look at the classic method, which has this great name, the VRF sandwich. After that, we'll get to the main event, Service Graph PBR, the modern solution. We'll see it work in a few real-world scenarios, and then we'll wrap it all up by talking about why this tech is, well, a total game changer. You know, at its heart, a network fabric like ACI is built for one thing: get packets from point A to point B as fast and efficiently as humanly possible. It just looks at the destination and goes. But security, well, security needs us to interrupt that beautiful, efficient path. We have to force that traffic to take a detour through a device like a firewall for inspection. And that's the million-dollar question, right? The network has its own GPS, its own routing tables that point straight to the finish line. So how do we tell it, hey, I know you want to go there directly, but you have to take this mandatory security checkpoint first? How do we do that without completely confusing the network's basic logic? That's the puzzle we're here to solve. This image right here, this sums up the whole concept perfectly. Look at the left. That's ACI's natural state. A client and a server are talking, and the traffic flows on the most direct path the fabric can find. Simple. But now look over at the right. With Service Graph PBR, we've inserted a policy. That policy acts like a traffic director, grabbing that flow and saying, nope, you're going this way, forcing it through the firewall before it gets to its final destination. The direct path still exists, but the policy overrides it. So before we can really appreciate just how slick PBR is, we got to look at how we used to do this. This is the traditional method, often called the VRF sandwich. And look, it works, but it brings a whole lot of complexity to the table. So a VRF, you can just think of it as a virtual router. It lets you slice up a physical device into multiple independent routing domains that don't know about each other. The VRF sandwich trick is to put your source, say a client, in one VRF and your destination, a server, in a totally different VRF. Now, the only way for them to talk is if you build a bridge between those two VRFs, and you build that bridge through your firewall. You're basically stitching them together via the service. And that's really the key here. You're not using a simple policy. You are fundamentally manipulating the network's topology. You're purposely building a more complicated path with multiple VRFs and all these external routing configs, just to make that firewall a mandatory pit stop. It's effective, but it's kind of a brute force approach. Okay, so let's put that complexity aside and look at the modern, much cleaner solution. Instead of messing with the network's plumbing, we're just going to use a policy to tell the traffic where to go. So let's talk about Service Graph with policy-based routing, or PBR. I love this analogy. PBR is basically a traffic cop for your network. Your routing table, that's like the road signs, it might say destination straight ahead. But the PBR policy is the cop standing in the middle of the intersection, waving their arms and saying, hold on, you web traffic, you need to take this detour through the security checkpoint first. It's a policy making the decision, not the routing table. And that is the big payoff. Because we're using an intelligent policy to redirect the traffic, we don't need to build those crazy VRF sandwiches anymore. We can keep our network topology flat, simple, and clean, and just let the Service Graph policy handle all the detours. All right, enough theory. Let's see how this actually works in the real world. Our first use case is securing what we call east-west traffic. That's just a fancy term for communication between two servers inside the same data center. Think a web server talking to a database server. Man, this slide just says it all. Look at the top diagram. That's the VRF sandwich. See those two separate boxes, VRF1 and VRF2? To get the client to talk to the web server, you need all these complex L3 outs, these external routing connections, just to stitch them together. Now, look at the bottom diagram. That's PBR. Everything is clean, simple, all living in one VRF. The policy just handles the redirection. The difference in complexity is just night and day. So this table really drives it home. Without PBR, you're dealing with multiple VRFs and a bunch of complicated routing. With PBR, it's one VRF and a simple policy. And check out that last line, because this is a huge deal. With PBR, you can be super selective. Maybe you only want to inspect web traffic. You can do that. With the VRF sandwich, it's all or nothing. Everything has to go through the firewall. Okay, for our second use case, let's talk about north-south traffic. This is the stuff coming into your data center from the outside world, or leaving to go out to the internet. Think of a user on their laptop at home hitting your company's website. It's your classic perimeter security problem. So on this slide, we've got 3 different ways to tackle this. The top design is simple, sure, but it makes the firewall the gateway for your servers, which means you lose a really powerful ACI feature. The middle one, that's our old friend the VRF sandwich, and you can see the complexity. But look at the bottom design. That's PBR. It gives us the best of both worlds. It's a simple, single VRF design, and the super resilient ACI fabric gets to stay the gateway for all the endpoints. And this right here is the key technical win. The ACI fabric has this amazing feature called an any-cost gateway. It basically means the gateway IP address exists everywhere in the fabric at once, which is awesome for performance and for letting things like virtual machines move around freely. Trying to make that work with a VRF sandwich is a massive headache. With PBR, you just keep it. No trade-offs, no configuration nightmare. All right, for our last use case, let's talk about a different kind of service. Everything so far has been about firewalls that are a routed hop, right? They have IP addresses. But what about services that are totally transparent? Layer 2 devices, sometimes called a bump in the wire. They don't do any routing. How do we shove them into the traffic path? And what do you know, the diagrams tell the exact same story of simplification. The old way, up top, is something called a bridge domain sandwich. A bridge domain is kind of like a VLAN in ACI. So you have to put your gateway and your server in different bridge domains to force the traffic through this transparent device. But again, look at the bottom. PBR just makes it easy. It uses a policy to steer traffic through that layer 2 device without needing all that extra network segmentation. So the pattern is pretty clear, right? The old sandwich method is rigid, it forces you to move your gateway around. The PBR method keeps the design simple, lets the ACI fabric be the gateway like it should be, and gives you that sweet, sweet flexibility to only redirect the traffic you actually care about. It's the same story over and over. Simplification and more power. So we've seen it in a few different situations. Let's just pull back for a second and summarize the big takeaways. Why is a shift from messing with topology to using policy? Why is it such a big deal for designing modern networks? I mean, here's the highlight reel. With PBR, you get to keep the gateway on ACI. You can stick a service between 2 endpoints in the same subnet, which is historically a really tricky thing to do. You can get super granular and only redirect, say, HTTPS traffic. You can scale your firewalls out horizontally, and it doesn't care if your service is a physical box or a virtual machine. It's just incredibly flexible. And you know, if you had to boil this whole thing down to one sentence, this quote from the documentation just nails it. You are trading a ton of operational complexity for the simplicity of a policy. And you get more granular control as a bonus. That's a huge, huge win. So this leaves us with one final thought to chew on. PBR and ACI is really a perfect example of a much bigger trend in our industry, right? We're moving away from manually configuring every little network path and moving towards just defining our intent with a policy and letting the system figure it out. So as our networks get more and more automated, you have to wonder, is this kind of policy-based control the future of how we're going to manage all traffic? Something to think about. Thanks for tuning in.